I'm Nalakshmi from Shri Venkateshwara College of Engineering. So today I'll be discussing a topic which is related to NoSql databases, that is version stamps. Effectively managing data versioning is a critical aspect of modern NoSql database systems. Version stamps provide a powerful mechanism to track changes, enable optimistic concurrency control, and resolve conflicts in real-time data streams. So, for introduction to NoSQL and data versioning, so NoSQL databases are designed to handle large-scale unstructured data with high availability and scalability, moving away from the rigid scheme of traditional SQL databases. Data versioning is the process of tracking and managing changes to data over a time, ensuring data integrity, auditing, and the ability to revert to previous states. The need for version stamps. Version stamps provide a unique identifier for each data modifications, enabling efficient conflict resolution and maintaining a complete history of changes. Firstly, we understand the need for version stamps. Also, for it's needed for concurrent modifications, auditing, and traceability, optimistic concurrency control, or scalable versioning. Concurrent modifications in distributed NoSQL systems, multiple clients can concurrently modify the same data, leading to potential conflicts that need to be resolved. Auditing and traceability version stamps enable tracking the complete history of changes, allowing for auditing, accountability, and the ability to revert to previous states. Optimized concurrency control version stamps facilitate optimistic concurrency control where updates are allowed but conflicts are detected and resolved at the time of conflict commit. Scalable versioning. Efficient versioning strategies are crucial for scaling NoSQL systems that handle a high volume of constantly changing data. So, versioning strategies in NoSQL databases are timestamp based sequence numbers hybrid approaches. Timestamp based using timestamps as version identifiers, allowing for chronological ordering and conflict resolution based on the most recent modifications. Sequence numbers assigning monotonically increasing sequence numbers to each modifications, providing a total ordering of changes. Hybrid approaches combining timestamps and sequence numbers to benefit from the advantages of both, such as preserving chronological order and ensuring uniqueness. Implementing version stamps in document-oriented NoSQL. Document structure. In document-oriented NoSQL databases, version stamps are typically implemented as part of the document metadata alongside the actual data. Timestamp versioning. Using the document's creation or modification timestamps as the version identifier, often complemented by a sequence number. Revision tracking. Maintaining a revision history within the document. Uh, within the document, allowing for retrial of previous versions and conflict resolutions. Distributed scenarios. Ensuring version stamp consistency and uniqueness in your distributed environment, leveraging technicals like vector clocks. So optimistic concurrency control with version stamps are read, modify, commit. Read clients retrieve the current version of a document along with its version stamp. Modify clients make changes to the document incorporating the retrieved version stamp. Commit. Upon commit, the database compiles the client's version stamps with the current version. If they match, the update is applied. Otherwise, a conflict is detected. So, conflict resolution using version stamps, last right wins, merge strategies, version branching, user intervention. The most recent modification based on the version stamp has considered the authoritative version overriding any conflicting changes. Merge strategies, merging conflicting changes by applying application specific logic such as selecting the most recent non-conflicting fields. Version branching, maintaining a branched history of document versions, allowing clients to selectively merge or revert changes as needed. User intervention, alerting users or administrators to resolve conflicts manually, especially for critical or sensitive data. Querying and retrieving version data, retrieve latest version. So query the database for the document with the most recent version stamp. Retrieve specific version. Query the database with the desired version stamp to retrieve a specific revision of the document. Range queries. Retrieve all document versions within a specific range of version stamps, enabling historical analysis. Time-based queries. Leverage the timestamp component of version stamps to retrieve documents modified within a given time period. Scaling version stamps in distributed no-scale. Scaling version stamps in distributed no-scale systems, cluster synchronization, ensuring consistent version stamp generation and management across a distributed no-scale cluster, often using techniques like vector clocks, sharding and partitioning data on version stamps across multiple nodes to handle high volumes of concurrent modifications and queries, monitoring and alerting, implementing robust monitoring and alerting systems to track version stamp related metrics and detect potential issues or bottlenecks. So, best practices and considerations: application design, integrate version stamps seamlessly into the application architecture, accounting for performance, scalability, and user experiments requirements. Data modeling, carefully design a data model to leverage version stamps effectively, considering factors like document structure, query patterns, and conflict resolution strategies. Monitoring and alerting, implement robust monitoring and alerting systems to track version stamp related metrics and detect potential issues or bottlenecks. So let's watch a video about the version stamps to understand much better.
Stamps help you to detect concurrency control. When you read the data, then update it, you can check the version stamp to ensure nobody updated the data between your read and write. That means, for example, now I am reading a value X, right? This is a transaction T. I'm reading a value X. Now in X, actually we have the value as 100. So if you read, what it will be done? It is as 100 only. So now you are subtracting 100 minus 10 you are doing. That means you are performing a write operation. Okay. And you are going to say commit. At the same time, T2 is a transaction. T2 is a transaction which is also reading the value as 100. Before you update the value, T2 already updated. Consider. T2 already considered. T2 has done 100 minus 20. So the value will be 80. That means in your between your read and write operation, a variable or a transaction is performing another update on your data. So here what is happening? A error will be occurred. Why? Because you are assuming that and you are writing something. Someone is assuming some value and they are updating some value. So here you may get conflict. So whenever you are performing write operation and commit operation on any transactions, first you have to see the version stamp of this X. So version stamp is nothing but the how many times it is updated, right? Now we'll see some examples in the following slides. So
Let's all about version stamps. I hope you understood what is version stamps. Thank you for watching this video.